Hello everyone. This is a video of basic electronics series, and I'm going to analyze inductors on it. First, I'll talk about the theoretical concept of inductors. Then I'll cover them practically. I'll start by defining inductor that is an electronic element, which stores electrical energy in a magnetic field. When current flows through it, inductor is also called coil and choke. Imagine a wire that voltage is applied to its both sides. You can see the electromagnetic force that's created around it using a compass. The direction of the force is determined by right-hand rule, and by putting your thumb pointing in direction of current. The four remaining fingers will show the direction of electromagnetic field. You might be curious to know about the field's origin and how it converts electric current to magnetic field. Are very broad questions that I'm not going to talk about on this video. But you need to consider that this field is perpendicular to current. Now let's change the wire with an inductor. As I said, when current flows through a single wire, it creates a magnetic field around it. And by increasing the number of turns of the wire, the field gets stronger. Value of magnetic field has a direct connection with number of turns and cross-section, and has an opposite connection with the length of the tube. And by placing ferromagnetic core inside the inductor, the field gets amplified, meaning, inducing capacity of an inductor with an air core is less compared to an inductor with iron core. And the reason is that the polarity of ferromagnetic material is chosen randomly at first. And by putting ferromagnetic material in iron core of an inductor, as the inductor creates a magnetic field when current flows through it, it makes the polarities be in same direction. Therefore, they amplify the magnetic field. I made an inductor using wire and iron core. And by applying voltage to it, paperclip gets attracted to the inductor because of the magnetic field around it. For a better understanding of the effect of ferromagnetic material on amplifying the magnetic field around the inductor, I'll remove its iron core. And by applying the same voltage, you'll see that the inductor can't attract the paperclip. But it doesn't mean that there is no magnetic field around the inductor. There is magnetic field, but it's not strong enough to attract the paperclip. Now let me tell you what field is. A range, area, space or any place that has a specific feature is called field. For example, electric field, magnetic field or any other field. Now that you know the definition of a field, let's compare capacitor and inductor. Capacitor stores electrical energy in an electric field, while inductor stores electrical energy in a magnetic field. You might wonder, why isn't the purpose storing energy and releasing it in time of need? So why does it matter if it is stored in an electric field or a magnetic field? The answer to that question is that magnetic field has features that electric field doesn't. Magnetic field resists changes. Meaning, if the current that passes through a magnetic field increases, it will resist the increase and vice versa. So inductors store electrical energy in forms of magnetic fields and resist increase and decrease in current. Let me show you it in a motion graphic. Note, all of this process happens in less than a second. Imagine there is a circuit like this one, and by applying voltage to it, at first, the current gets divided when it reaches this part, and it reaches the bulb and inductor. At first, most of the current reaches the bulb, and as you see, it turns on. What's the reason? Because as I said, inductors resist current change. And as the current is entering the inductor, in this way, the inductor resists it by generating back EMF power and prevents current entrance. Again, I'm not going to talk about the origin of power and why this happens. After some time and when back EMF decreases, input current of inductor gradually increases, and the increase of input current to inductor amplifies the generated magnetic field around the inductor. When magnetic field around the inductor reaches its maximum limit, which depends on the physical features of the inductor, such as number of turns, cross-section, tube length, and ferromagnetic material that is used as its core, back EMF will fade away. And the reason is that the inductor is filled to capacity. Therefore, there is no current change on the inductor, so that the inductor would resist it. In this way, all the current will flow through the inductor, because the bulb is a bit resistant. While inductor resistance is so insignificant, so it acts like a wire, and almost all current flows through the inductor and bulb turns off. Now let's remove the power supply from the circuit.